Hey guys, welcome to today's video. The problem of the day is determinant of a matrix. The problem is pretty much straightforward. We are given with the n cross n matrix and we have to find the determinant of the matrix. So the people who knows mathematically how to find the determinant of a matrix can skip this part, and for others we can take an example. So to determine a determinant of a matrix, we have to keep in mind certain points. The determinant of a matrix of size 1 cross 1 will always return the value in the matrix itself. The second point to be noted is to find the determinant of 2 cross 2 matrix. The formula is A into D minus B into C. So in this case, 2 into 4 minus 3 into 1. So it will be 8 minus 3 and it is 5. So this is the determinant of the 2 cross 2 matrix. The third point is to find the determinant of a 3 cross 3 matrix. Let's say this is our 3 cross 3 matrix. So now how to find the matrix determinant? In this case, we have to find the cofactor for each element in the first row. So the cofactor of 3 will be minus 1 to the power I plus j, where I is the row and j is the column. We will multiply it with the submatrix, which is the elements which are not equals to the row and column of the element. Means we will exclude these elements. So the values in a submatrix will be 3 0 and 2 3. Now for 2, the cofactor will be 2 into minus 1 to the power row plus column into the submatrix. And how to find the submatrix? Again, the elements excluding the row and column where the element is present. So here 2 0 1 3, 0 1 3, and at last the cofactor of 1 will be minus 1 to the power I plus j into the submatrix, which is excluding the elements present in its rows and columns, the rest of the elements. 2 3 1 2. So if we calculate this, we will get 3 into minus 1 to the power I and j was 1 and 1 in this case, so it will be 2 into. So we have seen how to calculate the determinant of 2 cross 2 matrix. That is, we can simply do 3 3 9 and 0. Now for the next part, it will be 2 into minus 1 to the power I was 1 and j was 2, so 3. I was 1 and the j column was 2, so total 3 into 2 3s are 6 minus 0, and lastly 1 into minus 1 to the power I was 1 and j was 3, so 4 into 4 minus 3. Further calculation will give this will be positive, so 9 into 3 is 27, plus this will be a negative value, So minus to 6, 12, and this will give us positive value, so plus 1. So it is 28 minus 12, which is 16. So the determinant of this matrix is 16. Now what if we take an example of 4 cross 4 matrix? 1 2 3 4, 1 0 2 0, 3 2 1 0, 1 1 2 0. It's a 4 cross 4 matrix. Again, as we did it before, we have to go through each and every element present in the first row, find out its cofactor, and then we will calculate our final determinant value. So here for the first case, 1 with its cofactor will be multiplied by minus 1 to the power 1 plus 1 2 into its submatrix. In this case, submatrix will be excluding all the elements present in the same row and column. So we will get all these elements, that is 0 2 0, 2 1 0, 1 2 0. Similarly for 2 3 and 4 we will calculate 3 submatrix. Then we have 3 into minus 1 to the power 1 plus 3 into the submatrix, which is 1 0 0, 3 2 0, and 1 1 0. And for the last element, which is 4 into minus 1 to the power 1 plus 4 into 1 0 2, 3 2 1, and 1 1 2. So by this we can conclude that while finding the determinant for 4 cross 4 matrix, we have to find the determinant of 3 cross 3 matrix as well. Again, if we consider this example, when we are finding the determinant for 3 cross 3 matrix, we were calculating the determinant of 2 cross 2 matrix as well. Now if we come to 2 cross 2 matrix, let's elaborate it again. The cofactor of, we have to find the cofactor of each of the element in the first row. So the cofactor of 2 will be 2 into minus 1 to the power 1 plus 1 into the submatrix, which is the element not present in its row or column. In this case it is 4, plus the next element into minus 1 to the power 1 plus 2 into the submatrix, which is 3. Now you see, if we are calculating the determinant of 2 cross 2 matrix, we have to find the determinant of 1 cross 1 matrix, and the 1 cross 1 matrix always return the value of the matrix itself. So here we will get 4, and here we will get 3. If we calculate the value, 2 into minus 1 to the power 2, which is 2 into 4, that is 8, and this will give a negative value, so minus 3, it's 5. So by this point we can clearly say that we are performing same set of operation to our given matrix, then to our sub matrix, and by this we will continue our process till our size of the matrix become 1. So basically we are doing recursion over here. When the size of the matrix become 1, we will return the value inside the matrix itself. So it is a mathematical logic, and we also got to know that we have to use recursion to solve this problem. So let's get into the code. We are given with a function determinant of matrix. Let's take a variable which will store our final result equals 0. Now to change the sign of every cofactors, we will take another variable. Now according to our given logic, we have to iterate through our first row of a given matrix. So let us run a loop, and I equals 0, I less than n, I plus plus. And for every element in the first row, we will create a submatrix. So int submatrix equals new int, and the length of the submatrix will be n minus 1. Why n minus 1? So we have seen in our example that to find the determinant of 4 cross 4 matrix, we were making a submatrix of 3 cross 3. Let us see the example again. For determining or to find the determinant of 4 cross 4 matrix, we have to find, we created a submatrix of 3 cross 3 size. Again we can see this one. To find the determinant of 3 cross 3 matrix, we created submatrix of 2 cross 2, and for this one we have created 1 cross 1. So that is why we will create the submatrix of n minus 1 length. Then we have to enter the elements to this submatrix from the original matrix. For that we can create another method, get cofactor. So we will write a code for this method which will return the submatrix for ith element in the first row of our given matrix. Then we will add up the determinant value with the sign multiplied by the ith element of the original matrix ith element into, now we have to recursively call the determinant matrix function. Let us call it determination of matrix and pass the submatrix along with the size of n minus 1. I hope the logic for this is clear. And at last, after finding the cofactor of every element, we will change the sign. The sign was, let's take it 1. So the sign was positive 1 before. We will change it with negative sign. Now we have to complete this method. Here we will pass our original matrix along with our submatrix. Then we will pass our row, that is 0 for every case, because we have to find the cofactor of every element present in the 0th row only. So we will pass 0 and the ith element, and lastly the size of the original matrix. Now let's complete the method. So this method will not return anything, so we can say static void get cofactor ctor. It will receive a matrix, a submatrix, the row value, the column value and the size of the matrix. So how we have entered elements in a submatrix? Let us watch it again. So for 3 cross 3 matrix, when we were considering 3, excluding all the elements present in its row and column, we have inserted the rest of the elements in our matrix, submatrix. If we take a case of 2, excluding the row and column, all the matrix that was 2, 0, 1, 3 was added in its submatrix. So we will write the same logic. We will take two variables int I and j to keep a track on row and column. Then we will iterate through our original matrix 0 less than n I plus plus int column equals 0 col is less than n col plus plus. It will be row is row plus plus. So we will iterate through our original matrix, and if the row and column doesn't match, only then we will add the element in our submatrix. So let us use a if condition. If the row is not equals to the row of the element for whom we are finding the cofactor, and also if the column is not equals to the column of that element, that is C, then only enter the value into our submatrix. Submat in ith column and j column while increasing it equals to the value in our original matrix column. So we have used post increment. So at first value will be added in the submatrix in the position I comma j, and then we will increase the value of j. And if the value of j becomes equals to n minus 1, that is the size of the submatrix, if it is true, then we will update the value of j with 0, and we will increase our row for the submatrix. Now this function will generate submatrix for the n elements of the first row, and accordingly it will be called recursively by this function, and we will calculate the value of our determinant, and it will keep on calling until the size of the matrix become 1. As we have seen, when our size of the matrix become 1, we have to return the value in the matrix itself. So we will return the value of the matrix. So let's check if there is any issue. Determinant submatrix. Okay, so this is determinant NNT of matrix. We have taken determinant as a variable, so let's change it. Okay, the size was n. Let's change this. So as of now the code is looking right. Let us compile and check. Yeah, so it's giving the right output. Let's submit. So this is how we can do this code. If you find this video helpful, please like, share and subscribe, and let's meet in the next video.